guys all at least saw the first or the assignment zero, right, which was to pick a different game other than Uno and tic-tac-toe and kind of think through the sort of what would be the structure of it from sort of a programmatic kind of perspective. Yeah, get that up on Canvas. Shouldn't be too challenging. Okay, so we're going to start talking MakeCode, which is, of course, the reason we're here. And the MakeCode is sort of a language that can be used in a couple of different contexts. There's hardware that you can use. So there's this thing called a microbit, which is like about the size of like a credit card, roughly. And it's got an array of LEDs on here, and it's got little contact points that you can put like a banana clip and wire something up. And so you could like make one of the examples that they have is where you wire these banana clips up to like fruit, and then when you touch the fruit, it actually the electrical properties change, and you can sense that, and then like make that into a game controller, which is kind of cool, right? And then also you can do you can use this language to do some modding in the education version of Minecraft, um, and it's a little more feature limited than I would like, the Minecraft part, but c'est la vie. So what we're going to be using is MakeCode, specifically the arcade version, which is basically designed for making games and stuff like that. And I think that the point I mentioned is that, so for example, um, you can program in either the sort of block view or in the uh, sort of actual code view, either JavaScript or Python. Uh, and what's neat about it is that you can translate between them, right? So let's say you make this program in block code, and then you hit the JavaScript button. It'll sort of auto-generate the equivalent JavaScript, and so when we or Python for that matter. And so when we get to later on in the class, where I mean, eventually. Uh, the way I like to sort of think about visual programming languages is sort of like training wheels on a bicycle, right? Eventually, they get in the way, and it's time for them to come off, and it's time for you to ride the bike properly, right? Um, and so the graphical code is kind of like training wheels, um, and then eventually you guys will see that while yeah it's really great to get started with, it starts to get in the way of actually doing cool stuff, or more advanced stuff. Okay, so that's kind of where we'll get to, and you can actually get hardware for this thing where you can download the game to it, like a thing that's sort of like a Game Boy roughly, in terms of size. um, yeah. So you can also do some other stuff with it. So they've added now where you can program Lego robotics in this language also, instead of Legos. Sort of, they made up their own graphical language, which is kind of cool. Anyway, so yeah. But we're going to do the arcade version. So it's just arcade.makecode.com. And then everybody was able to sign in, and it just used your school email since we use Microsoft for our email system, which is kind of handy. And so that's a feature that they've actually added in the last year or so, because it used to be that there was no sign-in feature, and the only way that it saved your stuff was with cookies. And so if you went to a different computer, your stuff wasn't there, and it was kind of janky. But anyway, so right, okay. So let me just sign in real quick. Okay, and let me just start kind of a new project. Um, just to kind of, and let's take a sort of a look at what all we have at our disposal. Um, So you've got sort of this virtual representation of a Game Boy, um, that will simulate your code, and or run it, right, so that you can test it out, and you can full screen that and do other stuff too. And if you've got a game controller, it'll work with that. You can plug it in and do that, or if you download it to actual hardware, it'll work. Okay, so essentially, these are sort of our palette of options as to the different pieces that we have, in order to build a game. And they're sort of organized into, everything's color coded and, um, uh, organized into some sort of logical structure. And so what I want to just kind of do to start out is go through kind of what we have, sort of what's the palette of stuff. Okay, so we've got um, sprites. Um, Basically, any object that's moving around or in the game world, is a sprite, and that's basically just a 2D object with possibly some sort of graphics attached to it so you can see it. Um, but it's just an object. And these things can move around, and these things can run into each other, and there can be behavior if what happens if you touch an enemy, and so on like that. Um, and so you can define them. Um, there's physics, which is basically them moving around, and their position and velocity, and so on. And then there's effects that you can put on them, where you can have things like text or bouncing when they hit walls, or basically have them destroy. If they run into something, you can delete them, or something. You can have projectiles. So, in Mario or something, this would be like the Hammer Brothers that throw stuff, right? So you can have an object spawn projectiles, or like, let's say you're making like a space shooter game, like Galaga, or um, uh, what is it? Space Invaders or something, where you are firing like lasers or whatever. So you can have that sort of stuff. You can detect whether or not you have overlaps, which is to say collisions between different types of objects. And so you could use this in a lot of different ways. So, like, for example, in Mario, if the player overlaps with a mushroom, one thing happens. If he overlaps with an enemy, something else happens. And then, but with the overlapping, say, with the enemies, it gets a little more complicated, because with what happens if Mario overlaps with an enemy? Unless it's the top of the enemy, right? So where you're overlapping kind of matters, right? And if Mario was already small, then you die. If he's big, then he becomes small. And if what is it, like, if he has a power up, he loses the power up but stays big, if memory serves. Now, actually, I think in some of the Japanese versions, that's not the case. If you have a power up and you go back to Little Mario instantly, right? But I mean, you could have it either way, right? But I think the Japanese versions are a little harder, in terms of the mechanic. Um, you can have events that trigger when these things are created or destroyed. You can get a list of all objects of a particular type, um, and then you can change the graphics that are associated with any particular object. Okay, so all of that's the sprite stuff. In controller, well, this kind of makes sense, right? In and you can't actually program multiplayer modes for this, where you've got two players doing controls. Um, and so basically, this is going to sense whether or not buttons are being pressed, uh, tell a particular object that it can be controlled with a set of buttons, uh, and you can sense, basically, is a particular button being pressed or not, whatever. And then same thing with the with a second player, if you're doing a multiplayer thing. Okay, so that's all input. Um, Game is going to be all of the sort of things that run the structure. Um, On game update is something that's going to run continually over and over again. Basically, the update is anytime it's drawing to the screen, which is going to happen, 30 to 60 times a second at bare minimum. Um, and you can, have a game win or lose. You can reset the game, which basically is like stopping the program and restarting it all over. You can have prompts where it's going to ask for input or say things to the user, right? So you could have, welcome to the game, please type your name or whatever. And then dialogue boxes for text of various kinds. So like in Pokemon or something where there's a story and there's dialogue, you can have any of that sort of stuff. Music. So the music engine, well, you're gonna run out of them here pretty soon, man. So um, the music engine is music and sound engine is a little more limited than I would like. You can have sound effects, and that's fine, but there's really not anything for putting in your own sounds. Um, and in particular, you can't put in like MP3s for music, which is mildly annoying because you can't, like, you're a little more limited in the music department than I would like, but they probably did that so that there wasn't going to be like lots of copyright violation going on with people uploading games that have copyrighted music in them and so on. Okay. Yeah. Not no, which is also unfortunate. So yeah, the this other tab we should go in is for assets. So you've got the following things that you can make as assets, and you'll notice that sound is not one of them. Okay, which is somewhat annoying. So you're a little more limited in the audio department than I would like. And in particular, what you can't do is, I mean, you can make music by having uh, playing tones and having rests, but essentially what you'd have to do is, in a sense, take sheet music and program the sheet music in terms of a sequence of playing notes for however long they are, um, and um, and having rests of however long they are. The other thing is, I don't think you can have um, multiple tones playing at the same time. Okay, which is also annoying because, yeah. Um, so anyway, it's a little annoying, but it's okay. We'll deal with it. Uh, Volume and tempo control, obviously, and yeah, okay. Scene is going to have basically controls for the screen, background images or colors. You can have some effects. Um, and then the big thing that we'll use in like a Mario style game is what's called a tile map. So the worlds in Mario are not giant images. They're really just a grid of, okay, at this coordinate, put this type of object. And then as you're running around and thing, it's sort of scrolling across that map. And what's on the screen is only a small sample of the whole thing. Um, and those things are called tile maps. You can have as many tile maps as you want, and there's an editor for how to create these things and how to designate, for example, like in Mario, uh, the the ground, right? You can't go through the ground, but then there might be objects where you can gonna go through them. So you can designate a particular tile as being either solid or not, and you can actually change that property on the fly. So you can have like, let's say there's a wall and you get some sort of power up, and now you can go through it. You can do that sort of thing. Okay. Um, You can put sprites at locations of particular things. You can have, let's say, for example, in Mario, there's the uh, like the question mark bricks blocks, right? Um, so let's say that you want to get a list of all question mark blocks that are in the game, and so you can spawn an enemy at them or something. I don't know. You can do that. You can set what happens when a player either hits a wall or overlaps with a particular type of tile. So, for example, let's say the lava tiles that are in Mario, right? What happens when you run into those? You should die. Whereas if you run into just a regular wall, maybe something else should happen, right? So you've got those sorts of controls. Um, and you can get the coordinates or set the coordinates of particular things, and these are exactly coordinates, right? So it's basically what's the row number and what's the column number of the particular block that you're dealing with. You can check collisions. Um, basically, are you running into this kind of tile or that kind of tile? And then there's also camera control, which is to say, this is how you're scrolling around the thing, right? Is that you attach a camera to something, and then the camera can move around. Usually, what you would do is you would have it follow a particular object like the player, but it doesn't have to, right? So, if you're making like a cutscene or something, you could have it follow different things as they're moving around. And then you can do a sort of effect where it sort of shakes the camera a little bit. Kind of looks cool. Okay. Info is going to have sort of game mechanics. So there's some variables that are built in for you to use: score, high score, life. What happens if you hit life 0? Countdowns, uh, and also multiplayer life and things like that. You can define your own variables, but things like score and high score are sort of already defined for you because, well, they're in most games, so might as well put them there. So you've got that sort of mechanic. And then what makes this, of course, programming is loops, right? So, um, uh, and what did we say like when we were playing Uno last time, right? What was the overall structure of it, right? So you were going around, people were playing cards. There were certain rules as to what cards could be played at any given time and what to do if you couldn't play a card and all of that, right? But essentially, the game was a loop, right? It was a continuous loop that was running over and over again, and until there was a winner. Okay. And so, for example, this would be something that you'd probably put in a forever loop that was just going to run continually. And then you can have something that basically says, okay, when somebody has won, terminate this loop. Okay, stop looping. Uh, you can repeat a specific number of times. So, for example, when you were dealing the cards, what were you doing? Yeah, repeating 7 times, giving a card to each player. Okay. Uh, and, you know, so you can repeat a specific number of times. You can have pauses that you build in. Um, and then this is actually probably the one that you would use for the for the actual game loop. While there's no winner, continue doing this thing and then stop when there is a winner. Okay. Um, you can you can go through a list and basically say, okay, like let's say you've got 5 enemies. I want to go through the list of all 5 enemies and do a particular procedure for each enemy. Uh, and so you can do that. You can have break and continue, which basically breaks out a loop. And then there's this other thing that's the on start, which would be, is there a snippet of code that you want to run once, but right when the game begins, basically that gets the whole thing going. Yeah, okay. So, and obviously we'll go through all of these in more detail. Logic, well, this is the other stuff that we did when we were talking about whether or not somebody has won or whether or not playing a given card was valid or any of those sorts of things. What did we do? Well, we were making lots of statements that were of the form if then or if then else, right? So if a player has one card and they don't then say uno, then they get a penalty. Otherwise, they don't get the penalty. Okay. Or if you can play a card, great, you can play a card. If you can't, then you have to draw one. And if you can play that card, then you can play it. Or if you can't, then you lose your turn. Or I think some of you guys were you playing the variation where you had to continue drawing until you got something that you could play, um, which is kind of diabolical. Maybe not quite as diabolical as the stacking of the draw cards. Uh, so, do you guys know what I'm talking about with the stacking? Yeah. Okay. Okay. So anyway, so things of conditionals. If something is true, and you'll notice that you see where it says true, that thing is kind of in a pointy bracket kind of shape. Um, One of the things I like about visual programming languages is things that can either be true or false are different than numbers and are different than text objects. Okay, so these are all variables, but they're different data types. And the graphical languages represent these data types with a particular shape. Okay, so a thing with pointies on either side is a thing that can only ever be true or false. And numbers are have roundies around them. And what that means, of course, is that you can't mix up the different data types, okay? Because you can't use a true false thing the same way that you would use a number. Like, what does it mean to add true and true? I don't know. It doesn't mean anything, right? But adding two numbers does. Okay, so that's kind of nice. But what you can do with true and false things is you can do logical operations with them, right? So you can't add true and true, but what you could do is do true, something and something. Okay, so when would an and be true? Like if I said A and B, when is that true? If A and B are both also true, right? Okay, so they have to be the same, yes, but in that case, true. And if, let's say I had false and true, what is that? False, okay. What about false or true? That's true, okay. Uh, and you can think just in English basically here uh, for what these words mean, right? There's a reason we just stole the English words for it. Um, because if I ask you, do you have math class or computer science class today? What should you answer? Yeah, you would all answer true, right? Even if none of you were in math classes. It doesn't matter that you're not in a math, or that you are or are not in a math class because you were all for damn sure in computer science because you're sitting right here. Okay. Whereas if I asked, are you in math and computer science today? What would probably most of you answer? False, unless you happen to also have a math class today. Which does anybody happen to, just out of curiosity? Okay, well, anyway, I mean, let's say you did this afternoon or something, right? Then it would be true, but for most of you, it's probably false. Okay, um, you can negate things, right? So that just means false becomes true, true becomes false, right? That's not rocket science. Uh, and then you see this little arrow. If you click there, you can change it from and or and the oops. Those are the two that you've got to work with, and then of course not. Um, are there more logical operations than those three, and or and not? Yeah. Okay. So has anybody taken the symbolic logic class that's offered in philosophy? Right. Okay. So what other Boolean operations are there besides and or and not? Uh, More basic than that. Like how can you combine two logical things? You had implication. Uh, Obviously, there's and or and not, and there were special symbols for those, right? Did you guys talk about exclusive or? Okay, a hot minute. Yeah. Okay. So exclusive or um, would be so the example I like to use for this is if I asked you, are you in math class or computer science class today? Is it possible that actually both are the case? Yeah. Okay. Uh, if I go home and my mom asks me, do you want apple pie or cherry pie for dessert? What does she mean? I can only pick one of them, right? If I say I want a slice of both, she's probably going to smack me and not give me any pie. Okay. Uh, so, but she still said the word or in English, right? Um, so in English, the word or has two different meanings. Okay. One of them is inclusive or, where both things are possible. Okay. Do you have math or computer science today? Right. Maybe you don't have either. Maybe you only have one or the other, but it's totally fine if you happen to have both, right? Whereas with the apple or cherry pie, the the the, the operating assumption there is that I can't have both of them. I can only have one or the other, but not both. Okay, um, and but that isn't an option here, right? Sometimes, by the way, the or for the pie exclusive or is abbreviated XOR for XOR. Um, and the regular or is just or, right? Um, okay, fine. Uh, but it's not there in the list. Is that a problem? Why not? Yeah, okay. And so there's that, right? You can build if you have and or and not, that's enough to build all the other logical operations, okay? Because you can build exclusive or as A or B and not both, right? So you can define exclusive or in terms of those three operations by combining them in a clever way, okay? And that's why it's okay that you don't have it. Now, is it convenient to do that? Not really. Okay, it'd be nice if they had thrown that in. But c'est la vie, right? They didn't put it there, so we have to build it from scratch. Okay. Um, and then obviously you've got your true false objects that you can, define things to be true or false. Like, is there a winner? When the game starts, that should be false. When somebody wins, it should just change to true, and so on. Okay. Um, Variables. So this menu starts out blank because um, there are no, we have not created any variables, even though there are a couple that have already been defined. So, like, for example, score and those things that were kind of in that pink color. You can make your own variables and they can be whatever you want them to be, object type, what values, and so on. And then, of course, the most fun is the purple category because what do we have here? Math, right? Everyone's favorite. Okay, and so you've got obviously everything that you could possibly want, or well, maybe not everything. Uh, Arithmetic instructions. You can do remainder upon division. You can do find the minimum or maximum out of a pair of numbers. You can do square roots. If you hit the little drop down, you've got some other functions that you can do. So you can do trigonometry. You can do integer operations. So, you know, multiplication, division, that sort of thing. What else do we have in here? You can round things. You can pick random numbers. You can constrain a variable to be between two values. And so what that would be is, you know, I don't know, like, let's say that you were programming Mario, but you can never have more than 10 lives. I don't know why you do that, but you could, right? And you can have probabilities of things, and you know, for like defining random something or others. Okay, and we'll get into these a little faster than maybe you'd expect. There's this advanced tab, and in the advanced tab, okay, there's some stuff to do animation. There's stuff to do images. You can define functions, which are can't be mathematical in the same way that functions are in math class. You know, you put in a number, it spits out another number, that kind of thing. But it doesn't have to be. It can be something more than that. Well, like a function is to do like 12 instructions. And then you can, instead of having to list all 12 instructions, you could just say, do this function. And then that function is defined over here, it does it, and then it comes back, right? So, for example, with Uno, you could have a function that's like deal cards. And then you could just say deal cards, knowing that the actual list of instructions for deal cards is sort of written down somewhere over here. And when you hit deal cards, you say, okay, what's the instructions for that? You go through and do them, and then you go back to whatever's right after the deal cards instruction. Okay. Let's see, what else do we have? Arrays would be like lists of numbers or things of that sort. You can have text, obviously, also. Console, that would more be for debugging and trying to figure out if something's going wrong. And then, this is where it's going to get real fun, is extensions. Okay, so those are things that add either new items within one of these categories or a new category altogether. Okay, and so let's go through the extensions list and see what there kind of is. Okay, now some of these are not really going to be relevant for our use, but like for if you're doing this with actual hardware, then you know you need to be able to define how that hardware interfaces with the game, or if you've got like a light attached or something like that, then you can do that. Or if you've got your thing hooked up to like little motors and stuff, or you're using a controller, right? You've got to have stuff to set that up. Okay. The rest of these things are things that people have programmed to add in to extend the properties of sort of OG MakeCode, like some more advanced animation stuff. There's color-coded tile maps, which will make it easier to create tile maps. You can do color fading. You can do status bars, which is kind of cool, right? For like, you know, life or fuel or things like that. You can have a block where you can save settings. You can have data where you sort of like attach properties to a particular object. The tile maps is sort of built in, but the extension allows you to have more than one tile map and a few other things like that. You can have a mini map. You can have timers. You can have this thing is for story. You can have like some more advanced text features. And it is even possible to define your own extensions, but obviously that's a little beyond the point of a class like this. Okay, because you'd have to program the extension in Python and use sort of language that this is all really running on. The button combos one, I think like let's say you were making a Street Fighter game, or you wanted to have the Konami code in the beginning of your game. You guys all know the Konami code? All right, what is it? Select start. Yeah, yeah. Up, up, down, down, left, right. BA, select start. Yeah. So you could program in those sorts of things, or like you're making like a fighter game where there's different, like you have to hit down then forward and A to do this kind of move or whatever. I was never particularly good at those games as a kid. The like Street Fighter or Mortal Kombat or anybody into those sorts of things, or Smash Brothers now. Yeah. Uh, I don't know. You guys like Smash Brothers? Yeah. Yeah, me too. The button masher games. So when I was a kid, one of my friends, uh, so let's see, I had a Super Nintendo, and the two friends that I hate English. The two friends that we always did stuff together, they both had Sega Genesises. Um, and one of them, the games he liked to play were the fighting games and the sports games, right? So they'd come over, or I'd be at his house, and he'd fire one of those things up, and I'm just like, I don't know how to play this stupid football game. So he would just annihilate me. And same thing with the fighter games. But then, on the Super Nintendo, I was never into those sorts of games. So I had like Mario Kart. Uh, that we played for a hot minute. That was an awesome game. Let's see what else. Final Fantasy. Of course, I had Mario. Uh, but like the fighting games like Street Fighter or Mortal Kombat, the originals, uh, those were not really my thing. Uh, and of course, back then the two versions were a little different. So do you guys know the story about if you played Mortal Kombat on the Super Nintendo versus on the Sega, what was different? Yeah, the Nintendo was far less violent, or far less gory, should say, because Nintendo made the developer kind of censor it a little bit to make it more family friendly. And so there was a lot more blood. I mean, it was 16-bit blood, so how bloody is it really? But at the time, we were like, oh my God, this is amazing. And on the Sega, there was even a special code you could put in that would make it like even more bloody and gory, uh, which uh, which actually, I mean, is kind of sort of how Sega marketed, not that specifically, but they were sort of trying to market the Sega to a slightly older age demographic than what Nintendo was going after. And so, like, if you were a teenager, would you want to get caught dead with the Super Nintendo? No, because all the cool kids have Genesis, right? Uh, Now that said, when I got my Super Nintendo, I was what, like 9, 10, maybe sort of in that age range. Uh, and uh, I remember like doing a lot of research, which of course this is pre-internet, so it's not like I could, maybe I got on AOL and or CompuServe and dug around, but like yeah, the wide open internet was not a thing yet. Um, but like, which one should I get, right? Because they were the same price, and I could get either one, but obviously not both, right? And my the condition that I had to fulfill to get this thing, because I got it like at the beginning of a summer or something, is over the summer I had to read a bunch of books and do a bunch of math with my dad. And if I did all of those things, then I got to have the Nintendo. So parenting for the win, right? Um, yeah. So I was reading, like I read Journey to the Center of the Earth and uh, the uh, what else did I read? Sci-fi novels, things like that. So yeah. Okay, anyway, so there's lots of different extensions, some of which we'll not necessarily use. Others are going to be, whether or not you just want to use that functionality in your game. So, for example, the mini map, right? Not every game needs that sort of thing, but some games would really benefit from it. Okay, so anyway, that's kind of the palette of stuff that we have to work with. And now let's start to get our hands dirty and actually program some stuff. So to kind of get started, let me get out of this and go back to the main thing. Okay, so we're going to start with this beginner skill map. Okay, and this is essentially like a series of tutorials that will, you'll start to make different primitive games, and in doing so, start to learn the details of all of these different pieces. Okay, so it's arranged right as a tree, right? So we'll go into, oh, I don't know why this is glitching out. Okay, so what's the first thing we're going to do? We're going to make this stupid little greeting card. Okay, great. And then it's going to walk us through basically what do we do, and you'll notice that the palette of things that we have is not the full-blown thing, right? So they've, with the tutorials, uh, deliberately gone in to remove the stuff that you don't need from being accessible so as to keep it simple, right? Uh, okay, so let's just kind of go through this one, for example, right? From the scene category, set the background image to blah, okay? All right, set background image to blah, and then we're going to click this thing, and that will open up an editor that allows us to draw stuff in, right? Or in the case of the gallery, we can, um, let's see, what does it say to do next? Do you see the background you chose? No, let's go back. Okay, so we need to define our own background, or we can go in here and it's got a menu of predefined things that are built in. And then with my assets, you can uh, uh, save things that you create for reuse later. Okay, but let's just go in and we'll pick the birthday cake, whatever. Okay, and then hit done. And then if we go to next, do we see the background that we chose? So if I, in the game preview thing, do I see that? Yes. Okay. And if I pop this, then it'll show me the thing in the sidebar. Okay, great. All right, so let's go back to the tutorial. Yes, we do. Add a heartfelt greeting, click on the background, and add a hand-drawn message. Okay, so I can take this and edit and be like, happy. I mean, you guys get the idea, right? And, okay, hit done. Add some pizzazz. Okay, so let's do the start screen confetti effect. And then if I run this, let me do that. If I run it, you see it's got the confetti going on. Yeah, okay, great. All right, let's go back to the tutorial. Let's do a thing. All right, so let's do some of this music. Right, so play melody. Snap it to the bottom of the OnStart container. It would help if I followed the instructions. right? And then here, if we go into the gallery, it's got some things that are predefined, but let's just take, for example, the scale, right? Okay, you guys can't hear that because I've got the audio output set to my AirPods. So let me change the output device. Dang it, come. There we go. Or was that somebody's computer or mine? Oh, okay. I was like, great, it's done. All right, so output we want uh, this guy, okay, because that's the device. Okay, I need to turn up the volume probably, but you guys get the idea, right? This is just so how does this work, right? You've got this palette of notes, right? And the color coding here, does this remind anybody of anything? The color coding? No? Yeah, but why that color arrangement with the notes? All right. Well, how many of you guys um, remember these things? Yeah. I mean, it's maybe been just a few minutes since you played with one, but I mean, does anybody have like a younger siblings that are maybe in this age range, or relatives or something? No. All right. Well, I think that's what they were going for was to remind people of that. Okay, so you can play this melody or whatever, right? And they've got obviously some of these built in, um, so whatever. We'll just do this one, and let me, yeah, okay, great, and that's it. So let me hit OK, and let's run it. And oops, okay, so it should be the audio should be coming out. Let me change that on here. Okay, now it should work. Okay, whatever, right? Uh, okay, so obviously this was not exactly the most exciting thing to create, but you got to start someplace, right? And in particular, uh, they've added some of these, like this is an ultra basic tutorial. They've added a lot of these things over the last couple of years because the other tutorials that they started with were, you know, you could give this to a 6-year-old and they could do it, right? Okay, so next, okay, we're done. And great, now we get to move on to the next thing in the skill map. Okay, so now we'll click on this guy, right? Make a bigger greeting card. This will have text in it. Um, and, you can continue this. Uh, it locks, obviously, them. So like this one, make a clicker game. How many of you guys have played cookie clickers? Right. That game is kind of ridiculous that it exists, right? But it is kind of addictive, right? Um, whatever. Like, okay, so we could make one of those, and then this one is to make some sort of dinosaur game, right? And the point of the sort of going along the path is to uh, it will each subsequent tutorial step is going to add new things to the palette of options, right? So, okay, so there's those things. Let me go back to the main. Let me get out of here. Okay. The beginner skill map. Okay, so we'll go through that. And then there's this other one called Save the Forest. There's some other tutorials. I mean, so there's a lot of this stuff that, we're not necessarily going to do all of them, but uh, um, yeah, okay. And the skill maps, right? For example, so this sort of platformer, uh, game maker guide. This is the sort of original tutorial I sort of thought of, which was, um, uh, yeah, okay. So like how to make a space shooter kind of game, and use projectiles and things like that. Okay. So anyway, so oops, that's not what I meant to hear. Let's basically just spend the rest of time. I'll kill the stream and go through this beginner skill map and just kind of work through it, and we'll start to kind of get the basics, right? So kind of the mode for class is some of the time in class I want to spend basically just working and doing sort of studio stuff, and other times I'll want to like explain things collectively. So yeah, all right, good. All right, so I'll kill the stream because we don't need to stream that, and then let's just go through those things and start to get a sense for how this all works. Okay.